On a problem like this, where we're given this iterated integral and we want to sketch the region R, whose area is given by the iterated integral, we might want to rewrite the integral specifying which limits of integration we're working with so we know what the graphs look like. So basically, the integral from 0 to 4, since dx is last, is not just the integral 0 to 4, it's the integral from x equals 0 to x equals 4. The second integral is about y, so it's from y equals 0 to y equals x. And already, to me, that makes it easier. Then we're going to be adding to that guy the integral from, again, x is last, so x is equal to 4 to x is equal to 8. And then we would have this integral is about y equals 0 to y equals 8 minus x. Now, mathematicians always want to write the least amount possible. So that is, assumed that it's, about y or about x. Put our dy dx in. So when I see this, I'm going to look here, and what I see is that overall x is going to go from 0 to 8. And we have y equals x as a line, and we have y equals 8 minus x as a line. And so if x is 0, and we're going from 4 to 8, so I'm just going to go, I know I have to go across 8 for x, and I think for y, because I'm only going to have to go up 4. Now, we are given these lines, y equals 0 to y equals x. We also know that we're only dealing from x going from 0 to 4. So if y equals x, y will also go from 0 to 4. So the line y equals x is this line here, right? Just graphing points. And then there's going to, of course, be a shift here. So this line right here, oh, that's no good. This line right here represents the first portion, but it doesn't represent the iterated integral per se. It's just kind of the outline. Now, think about the line y equals 8 minus x. If we wrote that in slope-intercept form, it would be y equals negative x plus 8. Right? But it's defined from x is 4 to x is 8. So when x is 4, you'd have y as negative 4 plus 8. So 8 would be up, so you'd have a point up at 4, 4. right? And then when x is 8, which was all the way over here, I believe, we'll just connect the dots on this line. So the split occurs at 4 when x is 4. And if you put kind of a separator here, so you can literally look at these vertical lines. X is 0. Right? This is the line x is 0. This is the line x is 4. And this here is the line x is 8. And then on the y side, remember that we had y is 0 as a bound. So this here is the line y is 0. And then we also end up having the top parts are going to be defined by the graph. So I know this is a little more in depth than asked for. The first iterated integral, the whole thing, right? Whole iterated integral is this region right here. So this is the region represented by the iterated integral. And then on the other side, this one right here is this iterated integral. Now, it's often quite useful to find out what the integral looks like, because when I was working in my master program in mathematical statistics, a lot of times you ended up with a shape like this, like a triangle, and you just remember that the integral is the area between curves, and so we just needed the area of a triangle, and I was doing all these crazy calculations trying to figure out the lines and all this different stuff to figure it out. So it is good to always make a picture. So anyway, this is your picture, and hope you enjoyed the video. If you did, please subscribe, hit that like button, and share if you want to. Bye.